All right, so as we were going over this study guide, one of the first things that I asked everybody in here to do was to use your test-taking strategies. Yes? Where we are underlining key facts. So if the question is about radiation, then we're talking about something traveling in heat waves, and then we're looking in the questions or the answers for something about heat waves, or we're reading something about heat being transferred by a liquid, and then we're looking for the word convection in the answers, and we're crossing out things that aren't doing that. And there are some of us in here that did that, and some of us in here that chose not to do that. And I'm just going to I'm not putting any names down. That would be really embarrassing. But I'm just going to put some scores down of some things that people did. And not that this is a big shock. These same people that were doing it in class today like I asked them to also probably did the same thing on the benchmark and did very well. TTS is test-taking strategies. I don't have time to write all that out. Student 1, Student 2, Student 3, Student 4, and Student 5. These are folks that I walked around the class and they were using the test-taking strategies, and these are the scores that they got on the benchmark. Then I looked at some people in the classroom that were not using the test-taking strategy that I've asked you to use, and we've been doing this all year long, so it's not like it's something new. And I looked at their scores on the benchmark. Who could tell me the difference in those two sides? What is that almost an average of per thing there? What's the difference? You look at like the first one, there's a 28 percent difference. The second person, if you compare, that's 52. The third one, 32. The fourth one, 32. The last one, 28. That's roughly about how many extra points those people are getting just by showing their work. What do you? I mean, just guessing. Say, do what? I'd say 30, right? Because if you look at the first one, 60 to 90, that's pretty close, right? Number 2, 40 to 70 is not even close because that one was really bad. But number 3, 60 to 90, pretty close. Number 4, 56 to 86, pretty close. Number 5, 56 to 84, 30 to 86. That's roughly 30 points for most, other than the one person. And again, I'm not saying I want everyone scoring an 88, but I can guarantee you this right-hand side over here, they're going to do far better if they just try a little bit more. Just a smidge more. It's not asking you to do a whole lot. So we're going to go over a few of these today. My computer will let me. There we go. Number 1. We look at number 1. It says an unlit candle was laid on a table, and this is what I see, in front of a hot fireplace. That immediately triggers a very certain word in my head. What word should that trigger in your head, Landon? I hear radiation. That's what I hear in my head. Let's pull that down a little bit. Which most likely explains why the candle melted. Okay, so I'm pretty certain the answer is radiation, so it could be this one. Is there anything touching? No. So it's not this one. Could be this one. Is it anything touching? No. Okay. Just by using the test-taking strategies, we've gone from a 25%, if we were guessing, to a 50%, just by knowing the definition of radiation and conduction. Now, heat energy from the fire, says A, was radiated through the air into the candle, or the heat energy from the fire was radiated through the floor into the candle. What's the best answer? A. And you move on. Again, am I asking you to like super annotate? No, I'm asking you just to use just a little bit of common sense and work your way through these. It's not hard. What I'm asking you to do is not like overly difficult. What is the original source of most of the energy that people use? Energy that reaches the Earth's surface by radiation from the sun, convection from the sun, radiation from the Earth's core, conduction from the Earth's core. What are the two that I can get rid of, Jesse, that we have not talked about in class? C and D. We have not talked about any energy from the Earth's core. It's there. You've learned a little bit about it. You'll talk a little bit about it more, but that's not what we're talking about. Now, is energy from the sun radiated or is it convected?
Radiated.
Energy from the sun is radiated. And I don't even have to look at the answer key. I have not missed number 1 or number 2. Right? Yes?
Also, there's no air or liquid.
No. And we're good. We've answered it. How do you place an ice cube on the sidewalk on a warm day? The ice cube soon melted to form a puddle. What process caused the ice cube to melt? Heat transferred through the ice cube by convection. Maybe. If warm air is blowing over it, maybe. Maybe. Heat transferred from the air to the ice cube by radiation. Again, maybe. Heat transferred from the air and the pavement by conduction. Still kind of maybe, right? Heat transferred through the ice cube into the pavement. No, so through the ice cube into the pavement makes no sense whatsoever. So now we've got 3 good answers. Now I know that only one person came back and asked me about this. This is a tough question. Am I upset if anybody misses this question? I'm really not. You just kind of have to look through this and say, what's the best answer? All right, so I don't think convection in A is the best answer. Do you? It's a possible answer, but there's really two answers on here that I kind of like. It's either heat transferred by radiation, and the heat waves do move through the air, right? Or heat transferred from the air and the pavement by conduction. I'm at a 50-50 shot here, right? They both sound fantastic. Use your best judgment. This is going to be one of those that you might miss, you might not miss. Right? It is what it is. So again, if you answered B, I'm really not mad at you. If you answered C, I'm not really mad at you because it's a tough question. If you look here, was that question 3? Is that right? 1, 2, 3. If you look here, the best answer is C. Heat transferred from the air and the pavement by conduction. Am I mad at anybody that put radiation? I guess the only thing that kind of changes that is it's transferred from the air. That kind of makes it convection-y. But, I mean, the heat does have to move through the atmosphere, the air. So, I mean, I'm not mad if anybody missed that one. That's a tough question, right? Should we have missed 1 and 2? No. Can you miss 3? Sure. You're going to miss some. Did you see any hundreds? No, there were no hundreds. No, nobody got 100 on the benchmark, and I don't expect you to. There's going to be questions like that that are tough. What color reflects heat radiation the best? The best. That's the one thing. What do you think, Max? White. White reflects heat the best. Which color absorbs heat the best? Absorbs heat the best. Landon. Black. Moving on. Number 5. What conditions are necessary for heat conduction to occur between 2 objects? Now, I know because I'm not even looking at the answers yet. I know that in order for conduction to happen, like they have to be touching, and there has to be a difference in temperature, right? One has to be warmer than the other. The objects must be surrounded by air or water. If they're surrounded by air or water, then we're not conduction, we are convection. The two objects at different temperatures are different temperatures touching one another. Unless they have another answer that says, please don't answer anything else, this is the correct answer, I'm probably coming back to B. That's literally what conduction is, right? Two objects different, and they're touching. I really like that. Two objects, different temperatures, located close to one another. That's probably not. So I know that if I were to go to a light bulb and cut the light bulb on, and then I went over to the light bulb and I put my hand close to it, would I feel heat? That's called radiation. One object must emit energy as light and heat, and another object must absorb the energy. Does it always have to be light? No, it does not have to be light. So again, we kind of knew that B was the answer, but did we go back and check all of our other answers just to make sure? Yes. Again, is this a massive amount of annotation that I'm asking for? No, it's not. Which is an example of convection. There are two words that I'm looking for probably in here. How is convection transferring heat? Through blank and blank. Okay. Heat coming from a campfire, that is
Radiation.
a spoon in a bowl of soup becoming warmer.
Yes.
Maybe warmer water at the surface of a swimming pool.
No. Yes. Yes.
Yes. How does heat transfer in convection? Whoops.
Is the water cold? No.
Heat goes up,
No.
cold goes down. That's tough though, right? That's a tough one. Again, this is a really tough question because when you dive to the bottom of the pool, it should be a little bit cooler because of convection happening. It just should. Because it's going to have hot water going up and cold water going down, and it's slowly doing that all day long. But again, I think that's a better answer than B, but if you missed that one, am I super upset with anybody? No, probably not, because again, tough question. Heat transfer by convection. So again, gas or liquid. A glowing light bulb, that's radiation. Heating the atmosphere. What's the atmosphere made of? What is the atmosphere made of? Air is a... Cooking in a microwave oven is... And heating a piece of metal in the flame. Do you understand why heating of the atmosphere is a better answer? Yes? All right. All right, everybody remembers starting our project on Friday, right? We have the conduction, convection, and radiation. The rubric is there. Everybody has a hard copy. It's online if you lose it. And we're working on that, right? And Shayla's sitting there going, I don't know what I should put for convection. Well, you come back to a question like this one, Shayla, and you say, I probably would have missed that on the test. The heating of the atmosphere is convection. I would have missed that. I wasn't thinking about sea breezes and land breezes. I wasn't thinking about the heating of the earth and hot air rising and cold air sinking. Because when I heard the word atmosphere, I wasn't really thinking of gas. When you are working on conduction, convection, I guess it would be in here. When you're writing your examples, guess what would be a perfect thing to go back and put in? The question that you missed. I mean, you don't have to write the question, but you say, heating of the atmosphere should be somewhere in here because it's an example that you weren't super familiar with, right? Hot air balloons. People don't think of convection sometimes. That's one that you should probably put in your project. So as you're going through this, if there happen to be some of the ones that were a little harder, put that in there. If you didn't get this question about a candle in front of the fireplace, use that as an example on your project. Does that make sense? So we're using our study guide to help guide our project, which is going to help us learn a lot more. Like button and subscribe. Do it now.